Hi friends, Rishi here and welcome to Science with Rishi. Okay, in the last video itself I had told you I'm not interested in just mentioning you how the graph will look like, but rather I'm interested in explaining to you how this graph looks like in different cases when an object is moving in a straight line. Okay, so in this video we are going to discuss the same. That means the behavior of different graphs like the velocity time graph, the distance time graph, etc. when an object is moving in a constant velocity, constant acceleration, and even if the object is at rest. Okay, so this is somewhat, you can consider this as a base of the topic motion in a straight line, but the knowledge that you are getting from this, the idea that you are getting from this, it is not just confined to this particular topic. You can stretch it wherever, even into the mathematics also. So give maximum care for this. Okay, so shall we start? So because this is the base, let me start from scratch. Okay, you may be knowing all these things, but just keep it as but just keep it in your mind or take it as a revision. Okay, suppose you have a function y equal to f of x. So what does this mean? First of all, it means the value of y is changing according to the value of x by some method. Okay, for example, y is equal to 2x means if the value of x is 1, y is 2, because 2 into 1 is 2, and if the value of x is 5, y is 10, right? And you have y is equal to 2x plus 3. Like that you can have numerous functions, right? Let me write some examples here. Y is equal to x square, y is equal to 2x square plus 5x. Okay, so here in the first two equations the power of x is 1, right? 2x means 2x raised to 1 and 2x plus 3 means 2x raised to 1 plus 3, and in the third and the fourth the power of x is 2x square. So this 2 is the power. So I will say here the degree of the equation in the first two is degree is 1, and here the degree is 2. So what does the degree mean? Degree means the highest power of this function. Now if you plot a graph, just give some random values for this x, find out the corresponding y and just plot it in a graph. Okay, generally if you speak, keep it in your mind, this is very important. Generally if you plot a graph for a first degree equation, the graph will be a straight line. Okay, the graph will be a straight line. And if you plot a graph of a second degree equation, the graph will be a parabola. Okay, the graph will be a parabola. This is a general case. Okay, for the first degree the graph will be a straight line, and for a second degree equation the graph will be a parabola. Keep this thing in your mind because this is very helpful when you go to the distance time graph and the velocity time graph. Now what do you mean by slope of a graph? Okay, suppose you have a graph like this. Okay, what is the slope of this line? Suppose this is a b. Okay, so the slope simply means y by x. Okay, so here the slope of the line AB is y1, y2, x1, x2. Here the slope of the line AB you can take it as y2 minus y1 divided by x2 minus x1. And I don't have to explain to you that the line AB is of a constant slope. So wherever you are calculating the slope of this line AB, the value of y2 minus y1 by x2 minus x1 will be the same, right? Now let me take another line. Let me extend it to some point C. Here you can see this line has got flattened, right? It little bit became a flat. So here I will say the slope has reduced. Okay, here you can see the value of y is small corresponding to the value of x, right? So here I will say the slope has reduced. Now what will happen at this point? It has become steeper, by which I will say the slope has increased. Okay, so this is the general concept of slope. Now keeping these two things in your mind, that means how the graph will look like for the first degree and second degree equation, and what exactly the slope means, we are getting into our topic. How the graphs, the distance time graph and the velocity time graph will behave according to different cases. And because we are dealing with distance time graph and velocity time graph, we are dealing with two equations which you already know. V is equal to u plus at and s is equal to ut plus half at square. Okay, now let's see how the equation and how the graphs will change in different cases. Okay, now the first case, object is at rest. Okay, that means the object is not moving. How that in this case, how the graph will be looking like? This is distance time graph. Okay, ST graph. At all point the distance is not changing. Suppose the object is at 5 meter from the origin or from the reference. At all point it is at 5 meter, right? At all time, whether it is at 10 seconds or whether it is at 20 seconds, it doesn't matter. The object is at 5 meter at all time. So this is how the distance time graph will look like when the object is at rest. Now let's discuss how the velocity time graph will look like. Naturally, you know, when the object is at rest, there is no velocity and there is no concept, the concept of velocity time graph itself is not there. But let's interpret it from graph. Okay, what is the slope of a line which is parallel to x-axis? What is slope? Slope is y by x. Now let's take these 2 points at 10 seconds and at 20 seconds. Okay, 20 minus 10. In both 10 and 20 seconds, the object is at 5 meters. So it means 5 minus 5, which means the slope is 0. Right? And what does that slope means? Y by x, right? Y means distance and x means time. So what is distance by time? It is a velocity. So 0 meter per second. Right? So what can you interpret from this? The slope of a distance time graph will give you the magnitude of the velocity, right? And here what is the magnitude of that velocity? 0. So here the velocity time graph will be going through the x-axis. Okay, so this is the first case. Let's take the second case. The object is moving in a constant velocity. Let's see how the distance time graph and the velocity time graph will look like. Okay, let's take the distance first. See, the object is moving in constant velocity, which means acceleration is 0, right? So here s is equal to ut. This half at square will get cancelled and distance is equal to velocity into time. So s is equal to ut. This is same as y is equal to 2x or something like 5x, right? So this is a first degree equation, and how the graph will look like? It will be a straight line, right? So this is how the distance time graph will look like if the object is moving in a constant velocity. It will be a straight line and the slope of that line will be constant, right? And what is the slope of this line? We know the slope of a distance time graph is the velocity. So what will be the slope? Slope will be y by x, or simply the value of this slope will give you this velocity. Okay. So now let's go to the velocity time graph. How the velocity time graph will look like. Okay. So let's go to this equation. Here also a is 0, v equal to u. What does that mean? It's a straight line parallel to the x-axis, and at all point the velocity is constant. Now let's see, we know that acceleration is 0 when the object is moving in a constant velocity, right? Now let's check it graphically. What does the slope of this velocity time graph will look like? We know, we have seen it in just before, that the slope of a line parallel to the x-axis is 0, right? So here the slope of this graph is 0. And what does the slope of a velocity time graph is? Slope, we know slope is equal to y by x, and here it is v by t, velocity by time, which is acceleration. So we have found out that for a constant velocity, graphically we have found out that for the constant velocity the acceleration is 0. Now the third case, the object is moving in a constant acceleration, which means the speed is increasing in a constant manner, but it is starting from rest. Okay, so how these two equations are going to change? Starting from rest, which means initial velocity is 0. This term has got cancelled. V is equal to at, which means it is a first degree equation when it comes to velocity time graph. Just like distance is equal to velocity into time, here it is velocity is equal to acceleration into time, which means this is a straight line, and because this is starting from rest, this will start from the origin with a constant slope, and the slope and the magnitude of that slope will give you the value a. Okay. Now when it comes to distance time graph, here also the initial velocity is 0, so here ut has got cancelled. You have got half at square, by which the equation will look like y is equal to x square or 2x square or something like that, by which you have understood that this is a second degree equation and the graph will be a parabola. And because this is also starting from rest, s is equal to 0, right? So this will start from origin. Okay, so this is how the graph will look like when the object is moving at constant acceleration starting from rest. Okay. Now the fourth case, that the object is moving in a constant acceleration. It is already moving and the driver has decided to increase the speed of the car. Okay, let's see how the velocity time graph is. Here you have got a value for this u and AT is also some other value. Here the graph is not going to start from the origin because you have got some initial value for the velocity. Instead it will be something like this, okay, and this is the value of your u, okay, and the slope of this line as usual will give you the magnitude of the acceleration. And when it comes to the distance time graph, both ut and half at square has got some value, but still this is a second degree equation, so the graph will be looking like a parabola only. The only change is that this parabola is not going to start from the origin because the object is already moving and it is not starting from rest. So these are the 4 different cases, and hope you might have understood how the distance and velocity time graph are changing. So go through this video many times and keep the concept thorough, okay. So we will continue according to the text in the next video. Until then, Rishi signing off. Bye, take care, Jai Hind.